Hey everybody, welcome back to episode 63 of the video series in which we program an entire video game from scratch in the C programming language. We have a lot to do today, probably some pretty interesting things, so let's get cracking. First thing I'm going to do is I'm going to launch Visual Studio. Notice that my icon is gone for some reason for Visual Studio. I guess that doesn't matter. And launch our solution. And I just wanted to go over a couple of small housekeeping items. If we take a look in main, go all the way to the top. Last time I know that we went through the apply fade in function. That was a pull request that we merged into our project from a friendly contributor. I'm just letting you know right now that I renamed his color text symbol to color underscore NES underscore white, which is defined right here. Yeah. So I just wanted you to know that in case you're wondering what happened to that thing that we worked on in the very last episode. I simply changed the name of it. So now that we've talked about that, I can take it off the table. Updated draw debug text. Oh yeah, I'll show you this too. I'll go ahead and launch the game and show you what I'm talking about. Yeah, so all I mean is this right here. I just changed I basically condensed the debug text a little bit. That's all it is. So if you go look at the draw debug text function, you'll see that I've wang-jangled it a little bit. Okay, so that's out. Oh, there is one other thing I wanted to talk about. So this will be, I hope, the last time that I have to talk about address sanitizer. I've talked about address sanitizer a couple of times over the past few episodes, including the last episode I talked about it. There's one very crucial piece of information, though, that I did not talk about when it comes to address sanitizer, and that is, I'll show you. So as you can see in my project properties, I currently do not have address sanitizer turned on. So I'm going to run this. And, you know, normal run of the game, you'll see that here I'm rendering the title screen at, looks like it's something over 2,000 frames per second, 2,300 frames per second. That's well and good. Now let me go back here and turn address sanitizer on and run it one more time. You'll notice things are already taking longer. The loading of assets is taking longer. Now you'll see that my FPS has dropped on the title screen by about 2,000 frames. So we're at like 400 something frames per second instead of 2,300 frames per second. There's also one other thing I wanted you to look at, which was the memory usage of our process, which is hovering at around 370 megabytes. 300 wait. Yeah, that's 400 megabytes. And climbing. I don't even know why it's climbing. I don't know when it's going to stop climbing. Pretty sure we don't have any leaks in our code anyway, but memory usage is climbing nevertheless. So let me go ahead and exit. Turn address sanitizer back off one more time. Run it. Now, our frames per second is back, as well as our memory usage. You can see that our memory usage is holding steady at 115 megabytes. So what we're looking at here is that address sanitizer is an absolute disaster for the performance of your program, both in terms of CPU cycles and also in memory usage. So we're talking 3 times or more memory usage just by turning on address sanitizer. And then the CPU cycles went, the CPU performance went down by, almost a factor of 10. It's just abysmal. I could also run the same experiment using the optimized release build, but at this point, I don't really care. We know that it's bad for performance. But there is something very important to mention here. And again, I hope this is the last time we end up talking about address sanitizer. The question is this. The question that I had was, well, if I enable address sanitizer in my debug build, and address sanitizer doesn't find any issues with my debug build, can I then disable address sanitizer in my production build or release build? Assuming that since address sanitizer didn't catch any errors or flaws or problems or whatever in my debug build, then can I safely assume at that point that there won't be any issues with the release build? Therefore, I should be able to turn off address sanitizer. Turns out that is not true. That is not the correct way of thinking. Address sanitizer does actually catch, or I should say, address sanitizer is capable of catching memory issues in your release builds. It is capable of catching issues that occur in your release builds that don't exist in your debug builds. So there is value in enabling address sanitizer even on your release build. That being said, because it is so disastrous to performance, it's just too costly to keep enabled. I can't keep that enabled. It hurts too much. So what I would propose doing, and what was suggested to me whenever I asked about it, was you should create a third type of a third build type. Basically, you see, I have this menu up where I can choose between debug and release. Well, Visual Studio allows you to create additional solution configurations. So the proposal is, if you want to check your app with address sanitizer, create a third solution configuration and call it release build with ASAN or debug build with ASAN or something like that. That is the proposed solution if you really want to run address sanitizer. At this time, I'm going to just say not going to worry about it right now. I'm not that worried about it. When it comes time to really start trying to root the bugs out in our program, then yeah, I'll definitely re-enable it later on. But we're not at that point yet, so yeah, just wanted to talk about that. I think those are all of the things I had to talk about. Let me also check for any comments on my videos that may have come in. Okay, one viewer asks, are there any benefits in using raw input for mouse, keyboard, gamepad instead of the traditional way plus X input? So as you know, we're handling keyboard input. We don't care about the mouse at all for this particular game, but we are handling keyboard input using the quote-unquote traditional method that Win32 apps typically use, which is to capture them in our WinMain callback. What is it called? Main window proc. And this callback. Yeah, so every time you press a key, it sends messages to you, and you can catch them in this window proc. We actually are not really doing that. We're not handling keyboard input this way. We're actually using get async key state. And so the reason why we're using get async key state is because I feel like, because of the asynchronous nature of the get async key state function, that it's a little bit better at capturing the actual state of the keyboard key at the very moment that I check for it. For what I mean by that is when I process, or if I were to process keys in a queue like this in my main window proc, and I were to just capture like VK underscore whatever in my window messages, the problem is that all of my window messages, all of my keys would get backed up in a queue. Right, they would all get stacked up in a queue, and I could only process them once per frame during when I'm draining the Windows message queue. And that might work well enough. That would probably work well enough that, especially for this type of game, because this is not a very fast-paced action game that we're making. But if you were making a sort of game like, Street Fighter V Turbo Edition or something, where all of your movements had to be pixel perfect and frame perfect and had to perfectly line up with the input from the player, then you would have to really optimize and be a lot more careful. For us in this game, it's not so important, but there are other types of games where the latency of your input is very important. Anyway, back to the question, are there any benefits in using raw input? So the idea behind raw input in Windows, it's still not for latency. Like, raw input is not really going to affect your latency, or at least not very much. I mean, it might technically reduce your latency a little bit if you use raw input as opposed to using traditional key input like this. But what raw input is really for, what it's mainly for, is the flexibility to be able to support many different kinds of devices, such as joysticks, third-party joysticks, touch screens, tablets, all sorts of like different devices, any sort of like human interaction device. That's what you can handle with raw input. Whereas this model, where you just capture input from mouse and keyboard, might not be flexible enough. So, like I said, with raw input, you can bypass other sorts of like operating system level filters like mouse acceleration. If you want to bypass the mouse acceleration setting in the operating system, then you might want to use raw input to bypass that. But other than that, it really is not about latency. So anyway, let's move on. I think that's enough questions. So what I'm going to do now is I'm going to close Visual Studio, close it back down, and we're going to try something today at my work, at my job. The past couple of weeks, I have been training interns to try to bring them into our team, to try to induct them into our team. And in order to do that, there's sort of a baseline level that you need to be familiar with C programming, C++, Windows API, that kind of stuff, because we are Windows escalation engineers. We support the Windows operating system at the highest level, so we're in there reading source code, we're debugging memory dumps, this kind of stuff. So to that end, I have been teaching these guys about the C programming language, and particularly about the Windows API in class. That's what I've been doing. One interesting thing came up about about other compilers. Obviously, Visual Studio and the compiler that comes with Visual Studio, the Microsoft compiler that comes with Visual Studio, is of course not the only compiler around. There are lots of different compilers, especially for C and C++. One of which is Clang. Clang, or C, I guess it's pronounced Clang, right? Notepad. Clang. So do you pronounce it Clang or do you pronounce it C-Lang? I guess it's Clang. But anyway, it's a C compiler, and they make this C compiler for Unix, Linux. They also have a Windows port of it. And I was thinking, wouldn't it be cool if we could build our game using this compiler instead of Microsoft's compiler? I think it would be cool to try. So let's go find it. Clang for Windows. Okay. Clang.llvm.org, getting started. And let's see, releases. .12.0 download. Okay, so 12.0 is the latest version that is, sorry, let me increase my font size. 12.0 is the latest completed version, I suppose. There is a 13.0 in development, but 12.0 is probably what we want to download. Sources, pre-built binaries. Okay, maybe I click here. This takes me to their GitHub site. What do we have here? Clang plus LLVM 12.0, x86 underscore x64. No, where is it? I know it's here somewhere. Why don't I just search for Windows? Or Win32? There you are. Alright, LLVM 12.0-win32.exe downloaded. And it's virus scanning, I think. Okay, run it. I said run it. Okay, I click and nothing happens. So I'm going to click open containing folder. Oh, there it goes. There it goes. I think. Yeah, here it is. Okay, it started. By the way, you'll notice I downloaded this Windows PC Health Checkups Check Setup.msi yesterday. My PC is apparently not going to be capable of running Windows 11. My processor is a Core i5-6600K, which is sixth generation Intel, and it's it's dual core. I'm sorry, quad core, 8 threads. I think it's 8 threads. Maybe it's just quad core. Anyway, it works great. I still play like Warzone and things like this with it. So there's no compelling reason for me to upgrade. But apparently they don't want 6th generation CPUs to be able to run Windows 11, even though I have a discrete TPM 2.0 chip on my motherboard, because I have BitLocker enabled and all that kind of stuff. So I have a TPM 2.0, but because my CPU is apparently too old, I won't be able to run Windows 11, at least not unless something changes. Anyway, back on point, we're running welcome to LLVM setup. LLVM, I agree. It says do not add to system path. I do want to add it to path. Add to path for current user. That's what I'll do. It's going to install it in program files x86 LLVM. That's annoying that they is it 32-bit or 64-bit? I mean, Visual Studio is still 32-bit, I think, until the next version. I think Visual Studio 2022 or something is finally going to be natively 64-bit. Of course, it still compiles 64-bit programs. It's just that the IDE itself is 32-bit. Anyway, next, install. All right, it's installing. It has been installed on your computer. Click Finish to close setup. Okay, close, close, close. close. Windows Terminal right here. And okay, so Clang is successfully installed and already is present on my path. As you can see, if you type --help, you can see that Clang, this is a C compiler, and it has a lot of options. It's very complicated, it has tons of options, as you would expect of a C compiler. You know, the Microsoft compiler has tons of options too, so this is pretty much to be expected. And if any of you out there are Clang experts and have any tips for me, I would I would happily take your advice, because, like I said, I don't know very much about Clang at all. In fact, I never used it until last week. So here we are. It is important to mention that Clang, the C compiler, does not have a linker. It does not come with a linker. So I think everyone who is watching these videos at this point knows this, but in case you don't know this, all C compilers basically work in the same way, where they have multiple steps that you have to go through in order to end up with a finished executable. And it's like step one, you run the preprocessor, which the preprocessor is just like, you know, anything that has like hashtag, you know, pragma, hashtag include. Like when you include a header file in your C file, it's literally just a cut and paste, or copy and paste it into your source code. So the preprocessor is mostly like text manipulation. It's just that kind of stuff. And then, like, secondly, you compile your C files into object files. So you feed the compiler a C source code file, and the compiler makes object files. And then there might be some other there might be like some intermediary steps that aren't really that important, but the important one that is the point of this discussion right now is the step 3 or 4 is the linker, where it takes foo.o and links it all together into foo.exe. A better example would be if I had multiple source code files, like if I had foo.c and bar.c, then I get foo.o and bar.o right there, right? So I have these two .o files, right? And I need to take the linker is going to take all these .o files and link them together into the final executable that can, you know, easily be run by your operating system. Clang doesn't have this piece. It doesn't natively, or, you know, it doesn't come with that piece. No one has written one, I guess, for Windows. Obviously, there are other linkers for other operating systems, but for Windows, this is still going to use the link.exe. It's going to use Microsoft's link.exe, the linker that comes with Visual Studio. So that kind of bums me out a little bit, because if you were aiming for completely getting rid of Visual Studio, then this isn't going to quite get us there, because you still need the linker from Visual Studio. Even though we're not using Microsoft's compiler anymore, we still need their linker. So yeah, there's that. Okay, so secondly, I guess let's just get into it and see what happens. See, if I go to my directory, repositories, GameB. All right, I got all my files here. So, you know, with Visual Studio, it's just like you click on the play button, right, and it does everything for you. Compiles it, links it, all this kind of stuff, runs it automatically. Well, with Clang, you gotta do it yourself. I will say also that there is Clang integration into Visual Studio, which I don't feel like exploring right now, maybe later. But right now, I just want us to do this on the command line. So I'm going to create, so I need to create a new file, basically. And I'm going to call this file, I'm going to save it as users source repos game B. Yeah, right here. Okay, and I'm going to call it Clang x64 debug build dot bat. Save. Okay, so this is going to be a batch file that we can run from the command line that is going to build our executable, or, well, it's going to compile our source code. I'm going to make a comment, Clang x64 debug build batch script. There we go. Making batch files like it's 1999. All right, Clang. The first thing I need to feed it all of my source code files. So we're talking battle.c, we're talking character. Oh, let me increase the font size for you guys. Character naming screen.c, exit yes no screen.c, gamepad unplugged.c, main.c, of course, and then I'm going to use this character as a new line. That's old school MS-DOS type stuff, but it's all one command. It's all one line. I'm just using that little top hat character to serve as an escape character, basically. So it escapes my line break. Anyway, all right, what other files do we have? mini-z.c, new game areyouSure.c, opening splash screen.c, and options screen.c. I think those are all my C files. If not, I'm sure it will let us know. Oh yeah, it's not. We're not done yet. Overworld.c, stb underscore vorbis.c. Sorry, another line break here. What else? And did we do title screen? Title screen.c. Okay. All right, let me clean this up a little bit. There. What else do we need? So, okay, we need to tell it std equals 99. That's the C9. Oh, sorry, that needs to say C99 standard. So, as with Visual Studio, you can compile in all sorts of different conformance levels of the C standard as well as the C++ standard. You need to specify an architecture, and with Clang you can do print targets. There we go, print targets. This gives you a whole bunch of different things you can compile for. ARM processors, ARM64, MIPS, what all we got here? x86 and x64 is obviously what we're interested in. However, this doesn't really give me what I wanted. So Clang command line argument reference avx2. We need to tell Clang which features that we want, which CPU features we want to include in our binary. And we already know that we're using at least AVX2. AVX2 is the feature set that gets us YMM 256-bit registers, so that we can render our graphics a little faster. This is using these strings in your command line. That's how you turn all these features on and off. There's also a lot of presets that mix and match these things, and again, I can't tell you exactly which one is best. I can only tell you the one that works for me right now is -m architecture, or -m arch equals core AVX2. So that should get Clang to compile our our code, basically. In fact, I'm going to start off by omitting that parameter just to show you what it looks like. So let's do O0 for no optimization. Let's do -W all for show me all warnings. And then let's do, so you can also specify different pound defines when on the command line. In Visual Studio, there are certain things that Visual Studio defines that you don't necessarily know about. For example, when you build a debug build in Visual Studio automatically defines these macros for you, which is _debug and also just debug without the underscore. And that flag tells Windows.h and other various header files to take certain, different paths, depending on whether you're building a debug build or a release build. But since we are not using an IDE, we need to make sure that we specify these things on the command line. So I think we also do like Win64. There may be others too. I don't even know. Let's keep going. Of course, we need output, and then the output is going to be. Let's go back to our directory. Ryan, source, repos, GameB. If I run it from this directory, I would like for the output to show up in the same directory as what we're already making, what's already coming out of Visual Studio. So we're going to do -O for output ./x64/debug. And we're going to call it gameb_clang.exe. Okay, I think that's sufficient for now. I'm going to save that. And now we're going to see what happens when I try to build this. And I called it, what did I just call it? Clang. There we go. I'm going to run our Clang x64 debug build batch file. And hit it and see what happens. Okay, as you can see, it output a whole lot of errors and new warnings that we weren't getting before. So you know what, I'm not going to let this stuff stop me. I'm going to fix these errors. Don't be intimidated. Compilers, they emit hundreds and hundreds of errors. That's just what they do. But if you just take it bit by bit, you can overcome and achieve. I'm looking for a place to start. Let's start with these because I did just briefly talk about these. All of these, notice these are the Intel SIMD AVX2 data types. And these are defined in imm_intren.h, right? One of those intren.h header files, which is obviously not getting included here for some reason. And I feel like it should be, but for some reason it's not. Go back to my build file. So the first thing I'm going to do is I'm going to add this dash m arch equals core avx2. This bit I have found is necessary to get Clang to compile code that includes these avx2 intrinsics and data types. Let me fire up Notepad++. An update package is available. Okay, open main.c, open main.h, and you know what, while I'm here, I need to definitely put on something better. Can we do deep black? Save and close. And also let's turn on, let's see, is there a view function list? There we go. There we go. So now I've got basically Notepad++ acting as basically standing in for the Visual Studio IDE as my text editor. Naturally, you could use whatever text editor you like. I know Visual Studio Code is really hot these days, which is perfectly fine. If you want to use VS Code, use VS Code. Anyway, but what I wanted to show you was in main.h, I already have this included where I pound define avx and then I include imm intrin.h. So my thought process was, how could I have gotten those errors that I was getting before from Clang, even though it was telling me like underscore M256I was an undeclared data type, even though it's not. It's in imm intrin.h. Anyway, it was the dash m. Yeah, it was this core avx2 command line switch is what got it to work for me. So let me make sure that's saved. All right, now I'm going to run it again and see what happens. Okay, I'm back. It's actually the next day. Yesterday, while I was in the middle of everything, my family came over and I had to make my famous beef birria queso tacos. But now I'm wrapping up. So I did have to back up. I have to back up a little way because I made a mistake. When I originally downloaded Clang, I downloaded the 32-bit version right here. Mistake. What I should have downloaded was this one right here. So Win64. So I uninstalled the old one, installed the new one. That's why I was getting those errors that I wasn't familiar with last time. It's because I downloaded the wrong version of Clang, apparently. I needed the Win64 version. So, all right, let's see. Back to, where was I? We're at this point in our batch, our build script, basically, where, let's see. Yeah, I'm compiling all these things. Let's go ahead and try it. Clang. Okay, so you'll notice that I still get errors from the compiler, but it's a different set of errors. Actually, these are from the linker. But we didn't even get this far last time because we were running the 32-bit version. So there was a whole lot of weird type redefinition stuff going on. What matters is, as you can see, like these function names should look familiar to you. Unresolved external symbol, peak message, dispatch message, reg create key ex, all this kind of stuff. And that's because what I was alluding to earlier, where anytime you build something in Windows, there's a basic set of libraries that you have to link to. So we are going to do that right now using the -L switch, and I guess it's going to be open quotation marks. It's going to be our Windows SDK path user32.lib. And again, these are libraries that you would get with the Visual Studio, not necessarily the Visual Studio installation, but the Windows SDK installation. Okay, we got rid of all of those. Looks like we got rid of all of the unresolved symbol errors coming from Windows functions. So that's good. What I don't really know though yet, I don't really understand is if including one of these Windows libraries, user32, was truly enough, or if maybe Clang, once I included that one, maybe Clang automatically found everything, the other libraries that it needed automatically based on that path. Would be my guess, because I feel like that probably isn't enough. There's probably other stuff that I should link to, like GEI32.lib, for example. But if it's if it's not giving us any errors, I guess there's no point. But what I do have here is it looks like our linker is completely confused still at this point. And it's telling us that basically all of our globals are, I guess, how would you put this? Like in conflicting, or they're all. I know what I need to do. I just don't want to do it. So we need to go and modify our code a lot. Basically, all of these declarations in main.h. All of these globals, here we go, like this for example, G performance data. So if you go look, you'll find G performance data already defined in this other object file. And I remember a long time ago, when we started sharing these global variables across multiple compilation units, at that time, I assumed that I was going to have to use the extern keyword in order to achieve that. However, Visual Studio was not making me do that. Like, it was allowing me to build the project without putting the extern keyword on all these things. But that may be something that Visual Studio is doing that Clang, for some reason, is not able to do, or maybe Visual Studio was allowing me to get away with something that I shouldn't have been allowed to get away with, if that makes sense. But basically what I'm going to have to do is I'm going to have to extern all of these. And so without further ado, I'm going to have to do that. I'm going to go ahead and do that. So the annoying part about this, though, is that even after I do this, so when you declare a global variable using the extern keyword, you also have to assign it a value in one and only one other compilation unit. So, for example, I'm also, in addition to adding the extern keyword to all of these things, I'm going to also have to I'm also going to have to initialize them all in probably main.c. So Let's go ahead and start this tedious process. Let's keep going, because it looked like my list of errors was getting shorter as I continued to do this. And essentially, like, I'll have to go back and check these more closely later, because you don't need to put the extern keyword on any global variables that aren't going to be shared across multiple C files. So, for example, if Gamepad ID is not used anywhere else except for in main.c, then there's no reason for me to extern it. So let's go back, build it again. Okay, I think my list of errors is getting shorter. G input enabled. And actually, I'm going to go ahead and close this and open it in Notepad++, so we can edit it from here. Okay, let's keep going. Right. Keep trying to get this thing to build. Oh, there it is. Gamepad ID, game window, asset loading thread, handle, all these things. Alright, let's see, what else? Let's go to battle.h. Maybe that one. Overworld.h. These need to be externed. We'll worry about the warnings next after this. Alright, it's getting smaller. Okay, Gamepad ID. What is the situation with Gamepad ID? There you go. There you go. G asset loading thread handle. Handle G current monster, which is in battle. Okay. Cannot open input file. Was it giving us that one before? Okay. Windows kits. 10. Oh. I had my path wrong, it looks like. So it should have been like the lib directory instead of the include directory. Where are you? Clang build script. Okay, see program files. Yeah, see I had to include right there. Should have been lib. I don't understand why that was working earlier though, to get rid of the message about unresolved externals you know, peek message and draw message box A and all that kind of stuff. I don't get it. Okay, so stretch DI bits, that's in GDI 32. So let's include another library here, WinSDK path GDI32.lib. Let's just work down the list. Ggame input. Okay, I need to go to main.c. And I have to initialize all these things. So after I save that and I recompile, I should no longer see it complain about Ggame input. So all of those symbols that I marked as extern, they need to be initialized. Yeah, G current game state. Yeah. Okay. Game state. Okay. Performance data, input enabled. Basically just fixing these two at a time, 2 or 3 at a time. Performance data. You can just initialize all these to 0 or whatever you want. What was the next one in the list? Input enabled, which is a bool, right? Hey, wait a second. I wonder if this is. I wonder if I could do this. Yes or no? Let's find out. What's the shortcut for save all? Yeah, see, it's still G input enabled, already defined in. So that is not helping us. That is not helping us. It has to be done in main.c. What's the next one? Music battle intro. G music battle intro. 01. Which is probably in battle.h. No, no, because we load it here in main, so we have to initialize it here. Accidentally closed that. Let's take care of some of these warnings just to make our output cleaner. Starting with this one. Illegal character encoding in string literal. These blitzstring to buffer. It's the little arrows that indicate where on the menu you're pointing, what you're pointing at. And that's in title screen. There it is. It's these. For some reason it doesn't like those. Gotta do something like that, I wonder. Option screen. This is what I was looking for. What? New game, are you sure? Okay, the next set of warnings that we're going to take care of is basically it's complaining about every assert macro that I have in my entire project. And the reason why is because indirection of non-volatile null pointer will be deleted, not trap. Okay, so it's complaining about the definition of the macro itself, which is right here, this pound define. Basically, all I'm doing is I'm writing to a null pointer, and I'm purposely making the game crash, right? Visual Studio doesn't complain about that, but Clang is complaining about that. And I think it's essentially telling me that I should instead be doing something like this. Where is my assert? Okay. So Clang has these instead of intrinsics, Clang has this set of what are called built-ins, and one of these is called a built-in trap, like this. So instead of this piece, I would type built-in trap, like this. And I already know what the difference here is there's practically no difference. They do almost the exact same thing. Only difference is that this particular intrinsic, instead of intentionally crashing by writing to a null pointer, what it does instead is it calls the UD2 CPU instruction, which also causes the game to crash. It essentially causes us to break into a debugger, right? However, Visual Studio does not have this built-in trap intrinsic. It has something else. So what I'm going to have to do here is what I'm going to have to do is make, if I go back to my build script and I make a new pound define, and define Clang like that on the command line, that will let the compiler know that the keyword Clang here is defined when I'm building with Clang, as opposed to Visual Studio, right? So now if I go back to main.h, I can do if Clang else do something else. So the effect of this is going to be basically like, let's see, I can just copy this. UD2. So the idea here is that, first of all, none of this only matters in the case of a debug build, right? But if this is a debug build and I'm building with Clang, then I want you to define the assert macro as, you know, this thing has to be true, or else then use this built-in trap. Otherwise, otherwise, if I'm building with Visual Studio, then I want you to use the underscore UD2 which this is intrinsic to Visual Studio. So, oops, only Visual Studio understands this command, and only Clang understands this command. However, they do the exact same thing, which is to raise an unhandled exception by executing an undefined, that's what UD stands for, is undefined CPU instruction, right? And then of course if it's a release build, then the asserts do nothing. I think that is going to remove all of those errors concerning the assert macro. Let's keep going. Okay, still getting somewhere. We're still making progress. Okay, so it says suggest braces around initialization of sub-object. This is something else that a new warning that Clang is warning us about that Visual Studio never warned us about, which is good. And the reason why, and like I'm sort of questioning here, is it saying that we should add an extra set of braces here? Or is it actually literally just saying we should put our braces, remove the space between the... No, that can't be right. So the reason why Clang wants us to put an additional set of braces around these things is because, remember, we redefined our pixel 32 data structure as a union. So let's go ahead and go do that. Draw a window, Gamepad. All these need to be changed, really. Let's go to main.h. This definition is fine because it uses the C99 syntax. So I don't have to change that pound defined. I just need to go to, let's go to draw window in battle.c. Window, and it's asking me to put an additional set of braces around that. So I will. What else you got? Gamepad unplugged. And I should actually go ahead and fix all of these because I eventually want all of these to match the NES text color. So, why don't I just go ahead and do that now? Why don't I go ahead and do that now? Main.h. Yeah, it's color NES white is what I want it to be. What else we got here? Gamepad unplugged. Gamepad unplugged. Okay. Okay, exit yes, no screen. And then opening splash screen. Opening splash screen. Text color is used to create the fade in, fade out. So I probably, oh wait, that's static, so I do need to keep that. But could I replace it with this? I bet I could. Opening splash. Okay, we're almost out of errors, which is nice. I mean, out of warnings, which is nice. Okay, opening splash. Let's keep going. Wait a second. Loading. This needs to be a grayish color, huh? Color, NES, gray. It's a pixel 32. Bytes equals 0x 0 0 0 0 0 ff. Yeah, 32x 0x20. So it needs to be 20 20 20. There we go. Make a new symbol there, take it down here. You can go right there. All right, we good? One more in option screen, which is also gray. Screen equals color NES gray. Cool. There's another switch that you can add to the Clang command line build dash pedantic, which turns on even more warnings. But that is going to be an entirely a new can of worms that I don't feel like opening just yet. So I'm not going to turn that on yet. We're still dealing with these. All right, unresolved external symbol G overworld 01. Okay, let's go back and fix these. Main.c .h. Okay. This in main.c. G player. Which I think is a hero G player. G battle scene grasslands. And again, I don't, obviously like the organization taking place here, but I'll fix that some other time. Okay, that one we must have already dealt with. And then this one is an array, it needs to be initialized as such. Unresolved external, so create solid brush. Sure sounds like something that should be in GDI32. It definitely sounds like it. Oh, which I'm not linking to, of course. So let's go ahead and link GDI32. Co-initialize EX. We do need that function to initialize our audio library, XAudio2. So the library that you need to link for that is Allay. So let me go ahead and link Allay32. Okay, now we're down to stosd, underscore stosd. And that's an issue because I believe this stosd intrinsic is specific to the Visual Studio compiler. So, I mean, obviously stosd is an instruction that exists for the Intel CPU, but the Clang compiler doesn't understand it. And I don't know if anybody out there knows of a better way to get stosd, then please let me know, because I don't. But what we could do, Clang can do something that Visual Studio cannot do, which is inline assembly. I believe Visual Studio 2013 was the final version of Visual Studio that allowed you to do inline assembly. Now you can't. You can have .asm files, but you can't have inline assembly. So let's go knock that out. This is in draw window, of course, which the entire draw window function needs to be redone, I think. So where's draw window? It's in, oh, it's in main, of course. Main.c, draw window. Okay. So basically what it's complaining about is this usage of stosd right here, which, as I mentioned, is only understood by Visual Studio as far as I know. Stosd generates a store string instruction, which is rep stosd, and this works really nice in Visual Studio, but it Clang doesn't understand it, and there's like nothing, since it's an intrinsic, there's no like library that I can link to that is going to make the Clang compiler understand it. So instead, what I'm going to have to do is I'm going to have to if def Clang, then do that, else do stosd. Right? Makes sense. I'm going to start with the asm keyword, and that allows us to begin our inline assembly. The first thing I need to do is remind myself of how stosd works. Stosd, store string. The stosb, stosw, stosd instructions can be preceded by the rep prefix for block loads of ECX bytes, words, or double words. More often, however, these instructions are used within a loop. I don't want to use a loop. We can do this without a loop. EDI is assumed to be the destination operator. Okay, so EDI is the source, no, the destination, so it's the destination buffer is going to be EDI. And the source is going to be EAX. And then I've got to figure out how to do this little bit of pointer arithmetic that I have going on here. So you start at the beginning of the buffer, and then you add memory offset, which should be easy to do. So okay, so the first thing I'm going to do is I'm going to take memory offset, and I'm going to move it into the EAX register. The important thing to remember is when you're working with assembly, if you only plan on moving 32 bits, which we do because memory offset is an int, so we know that memory offset is only 32 bits. If you only intend to move 32 bits, then you have to remember to use EAX and not say RAX. You don't want to move 64 bits. You only want to move 32 bits. Because if I put RAX here, then I would move memory offset, but I would probably move garbage into the upper 32 bits of the register. So I don't want to do that. Let's see, what I want to do next is I want to move something else into, I want to move G back buffer dot memory into RDX. Now I want to combine those two with the load. LEA stands for load effective address, and it's really hard to explain the difference between load effective address and a move instruction, other than LEA, load effective address, allows you to do some much better, it allows you to do calculations basically. So anytime you see this sort of thing where you're trying to do arithmetic based on a pointer address, I have like a base address and then some index, some offset into that address, is pretty much always where you see LEA, load effective address. Right, what am I doing? It's EDI is the EDI? No, RDI. Sorry. RDI, and then I'm going to combine these two. RDX plus RAX times 4 should be the address that I want to get to. Now I can move something back into, I can move my color back into EAX, background color, back into EAX, and then finally I can do the count, which is width, right? The number of times I want to do this. And then finally call reps_d. So the idea behind assembly, if you're not familiar, is you essentially are just you're setting up your registers with the correct values and then calling the operation that you want the CPU to perform. This operation reps_d will automatically perform the operation based on what I set up in these registers. So this code right here, this assembly code, should more or less mirror this one line intrinsic that I have here for Visual Studio. Right? EAX. And just to make sure that the compiler knows what's going on here, I'm going to do a keyword pointer. Let's see. Move memory offset into EAX. Move GBack buffer memory into RDX, and then LEA RDX plus RAX times 4 into RDI. Then move, typo. Move background color into EAX. Finally, move width into CX. And again, since width, remember width is only 16 bits. See here, width int 16 underscore t. Since it's only 16 bits, that's why I went with CX there instead of like ECX or RCX. And then call reps_d. Yeah, that should be it. So now all I need to do is find everywhere else in this function where I use, make sure I'm doing that right, if def clang else do that. My tabs are being kind of silly right now. Okay, I have more. Clang, and I will go back and fix all this later. I feel like this entire draw window function probably needs to be rewritten. I don't really like it. I'll probably end up redoing it with just memset at some point. I probably don't even need to be doing what I'm doing right now. But I wanted to include inline assembly just for the fun of it. I think that's all of them. With this fresh on our minds, I want to move back to Visual Studio for a second and go back to this code. So search for stosd. Okay, so notice in Visual Studio our block that has the inline assembly is grayed out. It's if defed out because Clang is not defined. But anyway, so stosd, I'm going to set a breakpoint on this. Okay, now we've broken into our stosd instruction, and now I'm going to look at the disassembly. Windows, debug, Windows, disassembly. Here we go. Docket somewhere. I guess that's terrible. That's a terrible place to dock it. But anyway. Okay, so let's look at the disassembly of our stosd instruction right here. And you'll notice that it doesn't look like what I just wrote. And in fact, they don't even use the reps_d instruction. Even though I typed stosd intrinsic, which you think is going to be a stosd, it's not. Even in debug, so there shouldn't be any optimization. But even still, the code generated by Microsoft's compiler did not equate to a stos-d instruction. It broke down into a rep-stos instruction. And I think essentially what this boils down to is this is probably going to end up being faster than my rep-stos-d that I wrote up here. Although maybe not. I'll have to benchmark it and find out. I trust their optimization here, but at the same time, it is a surprise. I thought it would at least be, I thought that if I used an intrinsic, it would at least equate to, the CPU instruction that I actually wanted to use. But anyway, it does not, and this achieves the exact same thing, only it's using a regular rep-stos instead of a rep-stos-d. So anyway, I'll have to benchmark the difference between these two and see which one is actually faster, to see if my code, the assembly code that I wrote, is actually faster than the assembly code that Microsoft's compiler generated or not. There you have it, folks. We just compiled with 0 errors and 0 warnings using the Clang compiler. So let's run the game and see what happens. Gameb.clang. It's 489 kilobytes. Let's see. All right, here we go. Moment of truth. Ready, set, go. It crashed. The game crashed. Okay, let's find out why. First of all, let's go back to my build script and make sure that I set battle. Okay, what I did not do is, if you are going to debug, you need to put this in your debug build using Clang. You need to do -G, which you can read Clang --help. Come on. Thought Windows Terminal had search with Control F, but apparently not. Anyway, -G, lowercase g, mind you, is generate source level debug information, which we definitely want in a debug build. So -G. But there's another one called G code view, and you want both of those in conjunction. And what is G code view? Of course it wouldn't be, there it is, generate code view debug information. We want both of those, so we added those. Let's go ahead and rebuild our thing now. There we go. Notice that we got a fresh ILK file, which is used for incremental linking. We got a PDB file, which obviously is used for debugging, as you know. And then notice that the gamebclang.exe executable got much larger because there's debug information in it now. So we know it's going to crash if we run it. So run it, watch it crash. So you'll notice the two windows that popped up there, and that was the proc dump utility capturing memory dumps of the process as it crashed. Which, if you don't have the proc dump, sysinternals.com, if you don't have the proc dump utility, you can download it from live.sysinternals.com. It is proc dump. Okay, so download that, and then what you can do is you run a command line window, And you go and get proc dump, and you type proc dump. Let me make my text bigger. Proc dump -ma-i, and then specify directory. This instructs proc dump to install itself as the postmortem debugger, which will automatically capture memory dumps of every process on your machine that crashes, and it will store those memory dumps into the c:/dumps directory. And I don't know where I saved it, probably there. There we go. I saved it in my tools directory. So if you run that command, you can see that it writes to the registry and inserts itself as this AE in this AE debug registry key. And you can do that with any tool that is capable of performing the job. I mean, you can put any sort of debugger that you want here, but I chose to put proc dump here because you know, it's a very good little command line utility, proc dump is. So there we go. And now if you go over to the dumps directory, you can see that I've got a whole bunch of dumps here from various processes: photos, shell experience host, your phone, game bar, FT server, all these memory dumps from processes on my machine that have crashed at some time in the past, including, you can go ahead and delete all these things, including game B. Right, and here is we get 2 of these for every time we run the program. Why do you get 2 of them? It's because you've got first chance exceptions and second chance exceptions or last chance exceptions. So it captures 2 dumps every time, 2 dumps per crash of the process. So next question is, how do you open these? You can open these with Visual Studio. You can open these with any debugger, RemedyBG or WinDBG. I have WinDBG Preview here installed on my machine. This is WinDBG Preview. If you don't have WinDBG Preview, you can go to the Microsoft Store right here and search for it and find it. Search for it, it's right there. It's in the Windows Store, the Microsoft Store. Okay, down and you install, and then you got it. Okay, so open dump file, and then I'm going to open this memory dump file, and I'm going to hopefully be able to tell why my game crashed when I first launched it. Run K for show stack, and in fact, let me increase the font size here so you can see it. I typed the K command, which is show stack. The stack starts at the bottom with user thread start. You can see that I'm in WinMain. Now I'm in render frame graphics. I'm in draw opening splash screen. Now I'm in blitzstring to buffer. Let me do that again with these color-coded things here. So I started in WinMain, and then I get to render frame graphics, and then I call draw opening splash screen, and then I call blitzstring to buffer, and then I call blit 32-bit per pixel bitmap to buffer, and then I crash right there at user exception dispatch. So I'm going to click the frame for blit 32 bits per pixel bitmap to buffer. Increase my font size over here in the source code window. Dun, dun, dun. This is where we crashed right here, which is on one of these Intel SIMD intrinsics, MM256_load_SI256. So we're basically telling the CPU, I want you to load 256 bits of our memory into one of the YMM registers. So we have a situation where this Intel intrinsic is working in Visual Studio. It worked fine in Visual Studio, but now it's crashing when we compile with Clang. And that is a big fat bummer. So let me copy this function name and look it up. Moves integer values from aligned memory location to a destination vector. The address must be 32-byte aligned. So the description of this intrinsic is giving me a hint as to why it might be crashing. So if I go back to my source code, and I go back to main.c, and I go to blit 32-bit per pixel, yes, keep going. There we go. And I find this code, bitmap octopixel equals, okay, this function right here is crashing my process. And we just read the description of it, which tells me that the memory that it's loading must be aligned on 32-bit boundary. There is another similar intrinsic, which is mm256 underscore load u si256, and the u stands for unaligned. So this allows us to load from unaligned memory locations. The downside is obvious. I mean, needless to say, or I should say, it stands to reason that the unaligned memory accesses are going to be slower. There's going to be some sort of performance penalty for accessing memory that is not properly aligned. But let's just see if we can make it work first. So the question is, do I have any other instances where I call this? Just two. Okay, so I'm going to change them from mm256 load to mm256 load u. So now I can load this memory regardless of what its alignment may or may not be. I don't even know, or haven't even verified what the alignment of the memory looks like. I'm just going to give it a try. Okay, compiled. And now I'm going to run it, game B Clang. It's working. Okay. Well, there you go. It's working. However, I will tell you one thing, though, is I don't like just leaving it at this because obviously a load U is going to be slower than a load against properly aligned memory. So I don't want to settle. I don't want to settle for that. I will say that I have tried all sorts of different memory alignment techniques with Pragma Pack and align of attributes and all this kind of stuff. I've already debugged this ahead of time though, so I'll go ahead and just save you all a lot of time and headache and just tell you what it is. So if I go back to my build script, if I change this from 0, from no optimization, to 01, which is like the minimal amount of optimization, save it, save everything, okay, and build it again. Okay, it built. Here's my executable. Let's see, run it. Okay, it runs. I did notice an error there. When you saw the loading message down there, it was blue instead of gray. And I think that's because I messed up when I pound defined the, well, instead of telling you, I'll just show you. Okay, so somehow I've made this blue, and I don't know how. ARGB? Do I have my bytes in the wrong order? Because I thought this was R, and I thought this was G, and I thought this was B, and I thought this was A. But the fact that the pixel was blue makes me think that this is blue because it was, well, it was blue, and FF would be 255, which is full blue. So it must be ARGB. So A, R is 20, G is 20, and B is 20. But if that's true, would that then indicate that this is incorrect? Because I think the intent here was for this in the color NES white definition to be RGB. Because alpha, remember, we're not really doing alpha here, so maybe it's supposed to be FF, FC, FC, FC. Let me give that a try. Let's recompile. Okay, it's done. Run it. Yeah, it's back to gray now. So I think the pull request that we got earlier was incorrect, and we didn't realize it. Instead of, it's just you can't. It's really hard to tell the difference. When we took this pull request to get this text color macro, the whole point of this is that the original NES hardware didn't actually have pure white in the color palette. The closest that it had was FC, 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 which is really hard to tell the difference between that and pure white. But anyway, so now that you know these are ARGB and not RGBA. But anyway, I think that's everything. I introduced a new tool, WinDBG, here, which I think will become more and more, well, we're going to be using it a lot more from now on, as long as we continue to use the Clang compiler and not Visual Studio. So, please make sure and download this. But anyway, I'm like way over time for now. So we will definitely, I will teach you everything you need to know about WinDBG in a later episode. So don't be intimidated by it. I can definitely, like I said, teach you everything you need to know about it. That's all I have for today. So thank you guys very much for watching. If you have any questions or comments, please don't hesitate to leave those in the comment section below. You can also find me on Twitter, follow me on Twitter. You can also find this repository on GitHub so that you can follow along at home and do all the same coding that we're doing here. Lastly, if you enjoyed what you saw today and you want to see more of it, then please hit the like button and hit the subscribe button and leave a comment below. And that's all. So thanks for watching. See you next time. Bye.